Wow. Taylor Willis. Smack talk. Okay, here we go. We do 2 examples. You have a worksheet. I will teach you the shortcut either tomorrow or Thursday. I'm guessing that tomorrow you're going to have time to work on your worksheet. It says find the derivative. I'll get you a worksheet in a second. Find the derivative of the following function. State the domain of the functions and the domain of its derivative. So when it says find the derivative, we do this. F prime of x is equal to the limit as h goes to 0 of f of x plus h minus f of x all over h. One time a student asked me that formula for the test. I laughed at them. You have to know that. That's non-negotiable. I've already written it down a few times on previous tests, just with an A or whatever. What? Says find the derivative. So that's that. State the domain of the function and the domain of its derivative. Okay, so the question is, what is the domain of this square root function? Do you know what the square root of 2 minus x looks like? So 2 minus x, it shifted over how many units? 2 to the right. And if it's minus x, it goes back that way. Okay, if it was a negative in front, then it would go upside down. So would I be able to find the derivative right here? Yes. How about here? How about here? How about here? No. So that's not part of the domain of the derivative probably. How about at the endpoint? No. You can't take the derivative at an endpoint like that. So we would expect that that would show up. So if you look at this, it looks like your domain would be from negative infinity to positive 2. Now, if you were to actually look at that analytically, say the square root of x, or 2 minus x, you can't take the square root of what kind of numbers? Negative. So you would take the inside, 2 minus x, inside greater than or equal to 0. So negative x is greater than or equal to negative 2. Divide both sides by negative. X is less than 2, which is what we have right there, right? So you should be able to look at something and state the domain, know where it has values and where it does not, okay? So we have the domain. The domain of this function is negative infinity to 2. And now we want to find the derivative. So I set it up. The limit as h goes to 0 of, what's f of x plus h? Yep, got to subtract the h because you got to distribute it through the x plus h. Minus, what is f of x? 2 minus x, all over h. Can I plug the 0 in for the h? No, you got to get rid of the h. Multiply by the conjugate. Square root of 2 minus x minus h plus square root of 2 minus x. All over the square root of 2 minus x minus h plus square root of 2 minus x. Why can I multiply something by the conjugate? What is that value right there? It's just 1. Looks a lot different than 1, but it ain't. It's 1. Okay, so we multiply. Limit h goes to 0 of, yep, 2 minus x minus h. And then you don't have to do the middles, do you? So square root of 2 minus x times square root of 2 minus x. I have to distribute the negative. Negative 2 plus x all over. Just leave the bottom alone. Put the h times square root of 2 minus x minus h plus square root of 2 minus x. All right, what happens? 2's canceled, very good. You get a negative h on top, which divides to give you a negative 1 on top. You now plug in the 0. So you get f prime of x is equal to negative 1 on top. Yeah, you got square root of 2 minus x plus square root of 2 minus x, which is 2 square roots of 2 minus x. Well, if you plug in 0 for the h, you get square root of 2 minus x, right? And if you add that to square root of 2 minus x, that's 2 square roots of 2 minus x. You have 2 square roots. Got a parenthesis over there. Sorry. Looky, looky, looky. Now the square root's in the denominator, isn't it? Well, that changes things. What number can't you get in the denominator? 0. So what number would give you 0 in the denominator? 2. So now this changes to negative infinity to positive 2. Well, what did we say was going to happen? Can you take the derivative at an endpoint? Where did the endpoint happen? Oh, what's up now? Is that nice? Well, if you plug in 2, that 2? Which 2? We got 3 of them up here. So this one right here? Yeah. I have the square root of 2 minus x plus the square root of 2 minus x makes 2 square roots of 2 minus x. Kimball, you now have to say 10 nice things about math. Oh, yeah. All right, we'll split it 5 and 5. Okay. Matt, square root of x plus 3 plus 4 square roots of x plus 3 is how many? 5 roots of x plus 3. Okay, so we did the same thing. Because the one's on the outside. Very good. Okay. All right, so is the domain of the function the same as the domain of the derivative? No, it's just slightly different. You can see how it excludes the endpoint because you can't take the derivative right there. Okay, so let's do the next one. Which, by the way, again, we don't leave at the 15 today, folks. Don't care. After you're right. All right, limit is h goes to 0 up. Now we plug in x plus h. We're going to do the same thing here. Let's look at this function. What's the domain? What can't you have x be? Right, x cannot be 3. If you were to look at that graph, it would look something like this. We'd have a vertical asymptote at 3, a horizontal asymptote at 1. I'll teach you how to do that some other time. And, you know, you got that shape. So you can see you can take the derivative everywhere except for 3. So we would hope that that'll be the same thing when we actually take the derivative. So we check it out. Come back here. Limit is h goes to 0 of x plus h over x plus h minus 3 minus x over x minus 3 all over h. Any problems with that? I have a complex fraction. What to do, what to do, what to do? Common denominator. So multiply top and bottom by x minus 3 for x minus 3 times x plus h over x plus h minus 3 minus x over x minus 3. Multiply top and bottom of that by x plus h minus 3 over x plus h minus 3. That's all over h. Beautiful. Limit. H goes 0. Some people don't want to write the limit. My gosh, just continue to write it because we took so long to discover why we had to write it. I mean, they waited 2,000 years for that thing, didn't they? Oh, yeah. Oh, yeah. I look for ways to take off points on tests. All right. So we multiply it out. We got to FOIL that. We get an x squared. Then what? Sure, minus 3x plus xh minus 3h minus x squared. Take it away, Taylor. Yeah. All over x plus h. Oh. Yeah. X minus 3 times x plus h minus 3. All over h over 1, but multiplied by the reciprocal, and you get that h in the denominator. All right, yeah, course done, yeah. All right. All right, what cancels? Those cancel, those cancel, those cancel. The H's cancel off. I got -3. Awesome. All right, so let H go to 0. Yeah? Where's the only spot that is not? Yeah, exactly. X not equal to 3. So that's exactly what we should have come up with. We saw that according to our graph. Well, no, it says find the derivative and state the domain of the derivative. So we stated the domain of the original function, which was x can't be 3. And this time they were the same. They won't always be the same. You saw they'll be very similar, but yeah. What? Oh, you're really good. No, you leave in 7 minutes. 11:20. All right, I got a worksheet. Say goodbye, YouTube.
Goodbye, YouTube.
Later. Go do some math.